Hello children, how are you all? I hope that you all are doing great at home. I'm Meenakshi Kothiyal, your computer teacher. As all of us know that in the situation, it is safe to stay home. So we have planned the online classes for the students so that they would easily learn and understand. But before starting, it's my humble request to all the parents, kindly have enough space memory in your mobile so that you can easily download the videos. So, what we are waiting for? Let's get started. Children, today I'm going to start the first chapter of your book ICSE Understanding Computer Studies. Open page number 9 of your book, and here we are having our first chapter, Evolution of Computers. In this video, we'll study about the history of computers and early calculating devices. Let's read out the introduction. Children, the concept of number and counting began around 4000 BC. If you go back to history, you will come to know they used aids like pebbles, bones, fingers, toes, etc. for counting. With the development, they became more conscious of their belongings. Children, nowadays we do calculations with the help of computers and calculators. But if we talk about the history, people used pebbles, fingers, sticks, bones, and etc. for counting. Why? Because till that time, no computers, no calculators were developed. Gradually, the humans became more civilized. They started thinking to make the task of counting easier. Thus, first calculating device, abacus, was invented. Now children, calculations of weight, distance, time, etc. have always been essential for humans. That's why people need computers to make these calculations simpler. For this purpose, few calculating devices were invented. The first calculating device is abacus. Abacus was invented by Egyptians and later developed by Chinese and Japanese. Abacus is being used since 450 BC. Even today, the concept of abacus is used in pre-nursery, nursery classes to give the fundamental ideas of counting in a playway method. It is used as a visual aid to state the learning of mathematical concepts. Now children, here you can see a picture given in your book. This device is known as abacus. Now let us study about the working mechanism of an abacus. Abacus, a calculating machine, comprises a rectangular wooden frame on which vertical rods are fixed. These rods contain beads. This rectangular wooden frame is divided into two unequal parts, that is, upper deck and lower deck, as shown in the figure. The upper part, known as heaven, has 2 beads in each rod, and the lower part has 5 beads in each rod and is known as earth. These beads can easily be slided up and down. Each bead of heaven is equal to 5 units and each bead of earth is equal to 1 unit. Here you can see an abacus comprises a rectangular wooden frame on which vertical rods are fixed. This rectangular box is divided into two unequal parts. The upper part is known as heaven, which has 2 beads, 2 beads in each rod. And the lower part is known as earth, which has 5 beads, 5 beads in each rod. These beads are used to do addition, subtraction, multiplication and division. The abacus is still used. We can see them in our nursery classes and pre-nursery classes. Here in this diagram, we'll see how the numbers are represented on abacus. Now children, if we want to represent any number, we have to bring the beads near the divider. The extreme right rod, this rod denotes the units place, and this rod denotes the tens place, and this rod denotes the hundreds place, and so on. If no bead is present near the divider, here no bead is present near the divider, then the value considered to be 0. Here also no bead is near the divider. Again the value considered to be 0. Here again in hundreds place there is no bead present near the divider. Again the value becomes the 0. Now when a bead of the earth is brought near the divider, the value becomes 1. And when a bead of heaven is brought near the divider, the value becomes 5. Here you can see 2 beads of earth is present near the divider. That's why the value becomes 2 here. That is how the number 2,51,000 is represented on abacus. Now, the next calculating device is Napier's bones. John Napier, a Scottish mathematician, developed a manually operated calculating device named as Napier's bones. It was considered to be the world's first calculator that could multiply, divide, and find the square root of a number. In 1617, this machine was designed and developed but later modified to make it more useful. Using the multiplication tables embedded in the rods, multiplication can be reduced to repeated addition and division can be reduced to subtraction. In 1617, Sir John Napier invented a calculating device called Napier's bone. It was a set of 10 rods with numbers carved on them. It was mainly used for multiplication. Here, you can see the rods with multiplication tables embedded in it. An example of 7's table is shown here. 7-1 is equals to 7, 7-2 is equals to 14, 7-3 is equals to 21, and 7-4 is equals to 28, and so on. Now, the next calculating device is Pascal's adding machine. In the year 1642, a French mathematician, Blaise Pascal, developed an adding machine known as Pascal's adding machine, Pascaline. He invented this machine at the age of 19 years. It was the first ever mechanical and automatic calculating machine or calculator. This machine could perform only addition and subtraction. Moreover, multiplication can also be done with the repeated addition. Now children, in 1642, Blaise Pascal, a French mathematician, invented an adding machine called Pascaline. It consisted of a rectangular box with boxes and dials. Each dial had numbers from 0 to 9. Numbers were entered by rotating the dials. This calculator could only do addition and subtraction. Next comes Leibniz's machine. This machine was developed 30 years after the Pascal's arithmetical machine. A German mathematician, Gottfried Leibniz, developed a mechanical calculator in 1673 and named it stepped reckoner. It was based on the concept of Pascal's adding machine. Now children, a German mathematician, Gottfried Leibniz, developed this mechanical calculator and named it stepped reckoner. It was based on Pascaline, but could also do multiplication and division. Children, as I've already told you that Pascaline could only do addition and subtraction, but this machine can also perform multiplication and division. Now, in 1804, Joseph Marie Jacquard, a French inventor, devised a loom that used punched cards to direct the weaving pattern. It could perform all 4 basic mathematical operations: addition, subtraction, multiplication, and division. It was helpful to perform lengthy calculations. Now children, to understand this paragraph, you have to see the knowledge corner section on page number 30. Here, This device is known as Jacquard loom. It was designed by the French inventor Joseph-Marie Jacquard. It used punched cards to direct the weaving pattern. Now, here comes our next calculating device, analytical engine. Charles Babbage was a professor of mathematics in Cambridge University, England. In the year 1822, he designed and developed a machine known as difference engine. This machine could perform most of the mathematical calculations. After working on the difference engine for 10 years, Babbage designed another machine named as analytical engine in 1833, which could perform the tasks based on instructions. He thought to make it the first general-purpose computer. Unfortunately, his analytical engine remained a dream. Now children, in 1822, Charles Babbage, a British mathematician, invented the first programmable computer called difference engine, and in 1833 he designed the analytical engine. This machine has all the essential features found in modern computers, means it can take input, produces output, and can store the data and information. Now children, turn on to page number 14. Here comes a very important question. Shall I ask you? Okay. Now tell me, who is known as the father of computer? Yes, Sir Charles Babbage is known as the father of computer. And why? Because he had given the concept of the first form of computer based on that today's computers are designed. Now, here comes our Knowledge Corner section. Here we'll study about Lady Ada Augusta. Lady Ada Lovelace Augusta was one of the disciples of Charles Babbage. She worked on analytical engine and fulfilled Babbage's dream. It was her contribution that made the computer a programmable machine. She developed the concept of binary number system in programming techniques. Hence, she is known as the first programmer of the universe. The computer language ADA was named after her. Now children, as we all know that computer is an electronic machine, so it can only understand the language which is written in machine language, that is, which is written in the form of zeros and one. That's why a computer stores all the data in the form of zeros and ones. Data could be anything, text, image, videos or etc. And the binary digits are zeros and 1. Lady Ada Augusta suggested this method of storage and concept of binary number system. She is known as the first lady programmer. It was her contribution that made the computer a programmable machine. Okay children, this is now for today in this video. Now children, let's take a quick recap of what we have studied till now. We have studied about the early calculating devices, which are as follows. Devices. Abacus. It was invented by Chinese and Japanese. Abacus was the first calculating device. Next one is Napier's bones. It was invented by John Napier in 1617. Next device is Pascaline. It was developed by Blaise Pascal in 1642. Next is Leibniz machine. It was developed by Gottfried Leibniz in 1673. Difference engine. It was developed by Charles Babbage in 1822. Again, analytical engine. It was developed by Charles Babbage in 1833. Charles Babbage is known as the father of computer. I just hope the introduction was good. Kids, due to this COVID-19 lockdown, we are not going to be at a distance forever. All I mean to say that it will come to an end for sure. Till then, I want you to be safe, stay home and complete your assignments. Thank you.